Hey guys, wanted to give you a quick video on neutralization reactions, stuff we talked about last week for acids and bases. This is the level 5 problem from our challenge last week, and I just wanted to go over it because I know a lot of people didn't get to level 5, and then there was some confusion mostly about part D. I think once I do it here, you're going to be like, oh yeah, I remember doing that for our titration. So here we go. It says 100 mils of 0.05 sulfuric acid. When you read that, guys, you got to know that that is a strong acid, and you should know the formula at this point. This for sulfuric acid is H2SO4. That's one of the 6 you need to know for strong acids. So that's added to 75 mils of an unknown concentration. So that's something we're going to solve for here in part D of barium hydroxide. And again, when you read those words, barium hydroxide, you got to know that that is one of the 7 strong bases. So really, this is a strong acid, strong base reaction, and we'll talk about the pieces of that. So part A says write the balanced neutralization reaction. Okay, H2SO4 is my acid. That's the sulfuric acid. We write it as aqueous. That's going to react with the barium hydroxide. Barium hydroxide is Ba, which has a positive 2 charge. So it's BaOH2 in parentheses for hydroxide. That's also aqueous. We're going to form, so this is your acid plus your base. Whenever you do an acid-base neutralization reaction, you form 2 things. You form a salt and water. So our salt here is going to come from the cation from the base and the anion from the acid. So we make barium sulfate, barium sulfate. That's your salt. And then water. Water is a liquid, so we put an L next to it. And to balance this really quick, I'm going to see that I have 4 hydrogens total on this side and 2 oxygens. So I'm going to put 2 moles of water. So there's my balanced neutralization reaction. For B, what's the net ionic? I'll take you through the total ionic, and then you'll see how we got the net. So I'm going to break all of these molecules that are aqueous up into their ions, except for water, which is in the liquid state. So we have 2 moles of H plus from the acid. Again, it kind of makes sense. This is a strong acid. We know it's 100% going to dissociate. We have sulfate. We have barium. We have 2 moles of hydroxide. And those are my reactants. I'm going to go down the line here. On this side, we have barium again. We have sulfate again. We have 2 moles of water. And there's our total ionic. So to get the net, remember I cancel out the spectator ions, the ions that match both the reactant and the product side. They're not in the net ionic. So barium's gone, sulfate's gone. And now I can do my net ionic, which is 2H plus and 2 hydroxides, forming 2 moles of water. And there's my answer for part B. Part C says what salt is made, and like we said up here, when you do an acid-base neutralization, you always get a salt and water. So the answer is barium sulfate. And then the D part. Okay, so this is a typical problem you do when you do a titration reaction. So remember, the titration process is all about figuring out the concentration of an unknown or verifying the concentration of a solution. So here my known information is about the acid. I have the volume, the milliliters, and I have the concentration. I have the volume of my base, but I don't know its concentration. So that's what I'm going to solve for. Here's the one big idea that you need to know from this. It says when you mix these 2 volumes together, it neutralizes the solution. So at the neutralization point, or when you neutralize an acid with a base, what we have to understand is that the moles of acid equal moles of base. Okay, that's the concept that you really need to know in order to answer this. So, because I have the volume of my acid and the concentration, I can figure out the moles of acid that I use to neutralize the solution, and therefore I will know the moles of base, and I can use that to figure out my concentration since I have the volume. So it's as easy as this. I'm going to change the volume into liters. So zero point 0.1 liters of H2SO4. I'm going to multiply that by the concentration, which I'm going to write as moles per liter, just to highlight the fact that that's what M stands for. Again, remember capital M is moles per liter. And what you should recognize is going to cancel out as liters, and that gives me moles. So 0.1 times 0.05, and we get 0.005 moles of H2SO4. Whoops, there we go. Again, that's going to be my moles of base as well at the neutralization point. Barium hydroxide. And I divide that by the volume of barium hydroxide from the problem, which was 0.075 liters. Again, I converted the milliliters to liters. So we divide, and voila, there's my concentration of barium. Whoops. Hydroxide. There we go. Not the concentration of the salt, but of the base. So there's my answer to D, and I'm good. So big idea again you need to understand is whenever you're told you're neutralizing an acid and a base and you've reached neutralization or you've neutralized the solution, moles of acid are equal to moles of base. Hope that helps.